All right, in this lesson, we are going to finish up with the conic sections. And our last conic section is the parabola. Now, you are familiar with parabolas being referred to as quadratic, which two of the four types of parabolas are quadratic. The ones that open up and down are quadratic. But the ones that open side to side are not, because that means that the y is squared instead of the x. So not a quadratic equation in that case, but all four types of parabolas are considered conic sections. So just like in our other sections, if we start with the definition, every point on a parabola is equidistant from both a focus and what we call the directrix. And I've drawn, here's a little visual for you that illustrates this. So this is the directrix right here. And it should be perpendicular to the axis of symmetry. The focus is on the axis of symmetry on the inside. It's always on the inside of the parabola. And here's our definition for directrix. It's a line perpendicular to the axis of symmetry, which we already said. It's also always on the outside of the parabola. So focus always on the inside of the U shape, and the directrix always on the outside. The equidistant part is illustrated by what you see here. So we can see that this distance is the same as this distance. And then as you move out, different points on the parabola, it's true for all of them. And you can see that they've marked two more here where we have distances that are equal when I draw the perpendicular to the directrix and connect to the focus. All right, so let's look at our standard form equations. I wrote this out twice just because it looks a little bit different when we have the center at 0, 0 than if it is somewhere else. So if its vertex is at 0, 0, then you're just going to see either a plane x squared or a plane y squared and a plane y and a plane x. This 4p we're going to talk about as we get into the graphs, but p specifically is the distance from, so p is the distance from the vertex to both the focus and the directrix. So 4p becomes a constant because p we end up having a number for. So 4p becomes a constant that our plane x or plane y is multiplied by. You can see that when we change the vertex and we have vertical and horizontal shifts, like here, we still have that 4p multiplied in front. Very, very, very important that you pay attention, regardless of whether it's the x or the y that's squared, that the h part of the vertex is always with the x. So if the x is squared, then it's inside the squared. If the x is not squared, then it's still over here with the x. So oftentimes I get people who just don't pay attention and look really quick, and they always like take whatever's over on the left side and make that h, take whatever's on the right side and make that k. You want to make sure you avoid that common mistake. So this, I made a typo here. This should be vertex HK because we're going to draw it for the general form, not for the specific 0, 0. So HK is a general point, and we don't know where exactly that might be. But wherever HK is, let's just say that it's right here. So I've gone, in this case, to the right and down, but it could be any direction that we've shifted. If my x is squared and p is greater than 0, so meaning this constant for p is positive. If 4p is positive and the x is squared, that's going to create the most traditional parabola that you're used to seeing. So here's my HK, and as always, apologize that my drawing may not look super good using this tool. But that would be a parabola that opens up. When I have this type of parabola, I know that the focus is going to be inside, so it's going to be up, and the directrix is going to be on the outside, so it's going to be down. Because remember, the directrix, if you draw the axis of symmetry, which would be right here, the directrix has to be perpendicular to that. So in this case, it would be a horizontal line. So our directrix, in this case, we would have y equals, since it's horizontal, and the y value there, because it's down p units, would be k minus p. Then my focus, and try to make it look like it's equidistant here, focus would be inside. It's going to have the same x coordinate as the vertex did, but then I'm going to go k plus p for its y coordinate. So then what we change as I move to the next type of parabola, notice the x is still squared, but this time it says p less than 0, which means that our constant is negative. And so if that's the case, again, it doesn't matter where I put my h and k. Let's say I put it here this time. If this is my parabola, if my constant is negative and my x is squared, that's going to make a parabola that opens down. Directrix, again, has to be perpendicular to the axis of symmetry, so it's still going to be a horizontal line this time, but now I'm going to go however many units up. Now, p is negative, so when you add a negative, it actually makes a minus, right? But we get y equals, if this is at h, comma k, this would be k minus p still. So notice how even though one's positive and one's negative, we end up with the same idea, because I would add it, but since the p is negative, it becomes subtraction. And then equidistant, down here, I would have h, and then I would typically be taking away from k. So it'd be, taking the p distance away, but since p is negative, minus a negative becomes a plus. So ends up looking the same. My other two types are when we switch to the y being squared. So I have a positive for this one, a negative for this one, but when the y is squared, that means that our parabolas are going to open either to the left or to the right. When our constant is positive, it's going to go to the right side. So again, doesn't matter where I put my HK, could be anywhere. But once I have it, again, now my axis of symmetry is a horizontal line, and in order to be perpendicular to a horizontal line, I need a vertical line. So I'm going to draw my directrix here, and its equation is no longer y equals, it's x equals, and it's going to be the h coordinate, or the h value, not the h coordinate, it's the x coordinate, but we're going to go h, and then since I'm going to the left and it's positive, that means I'm subtracting, so x equals h minus p. and then try to make it the same distance because focus and directrix are the same distance from that vertex, then I would be adding to the h coordinate the p-value to get my focus. Last one. Let's say I put my HK here. So I haven't done one that's on the axis yet. So my parabola would look like this because if the y is squared and the constant's negative, it's going to open to the left. So if I put my directrix here, then that would be x equals, and again, since the p-value is negative, it's really like I'm doing the same thing. It ends up being subtraction because I'm adding a negative. Then equidistant in here, I'm going to have that focus, which is going to be h plus p k. So hopefully this gives you an illustration so you can kind of, quickly look and see what ends up happening with those. As I've done on all these conics, here is the formula sheet so you can see, what's going to be directly there for you. It tells you whether it's vertical, meaning opens up or down, or horizontal means opens left or opens right. Notice that this does not give you, so you will, need to know which the positive, negative, and whether it's left, right, up, or down. It does give you the vertexes at HK, and then focal diameter is 4P, which we'll talk about with the actual graphing. So let's move on to some examples with actual graphing here. So this one says, find the equation of the parabola whose vertex is at the origin and whose directrix equation is x equals 6. Then graph the parabola. So knowing that x equals 6 is the directrix, if I graph that, and really I probably should have on the previous page made my directrix really should be dashed when we draw it. So this is my directrix. They've told me my vertex is at the origin. So given this information, I know that it has to open left because the directrix must be outside the parabola. So I know that it's going to open to the left, which tells me that the y is going to be the squared value. Because it's centered at the origin, its vertex is at the origin, that means that I'm using this one, just the y squared equals 4px. So y squared equals 4px is what I'm going to be using. And really, then I just need the value of p. Remember that p is the distance to the focus and to the directrix. Remember that if it's opening left, I need my constant to be negative. So whatever that distance is, I need to make it negative. So distance from focus directrix from the vertex. So in this case, from the vertex to the directrix is 6 units. So that means that I'm going to plug in -6 for that p-value. And so then I have y squared equals 4 times -6, which is -24. So -24x. So this is my equation. Then it asks us to graph the parabola. So where it said absolute value of 4p is the focal distance, what that means, what that tells us is that the length at the focus the width, I guess I should say, of the parabola at the focus is 24 units. So if I go and plot my focus, which should be 6 units the opposite direction, 1, 2, 3, 4, 5, 6, that means that at this point, I should be able to go 24 total units to get the width, which would mean 12 units up and 12 units down. So on your graph, you need to be able to do that in your homework. Now here I picked coordinate planes where I couldn't, I didn't change the scale. So I don't have enough room in this case, but basically the amount of room I have, the width of that parabola should be double when I get there. So this parabola should be super, super wide. And there I've got my picture. All right, let's look at another one. This one gives us the equation, asks us to find the vertex, focus, and directrix, and to graph it. So much like we've done in the other sections, this is not in the standard form for a conic parabola, so I'm going to need to do some completing the square. With the parabola, it's nice because you're never going to have to double complete the square because only one of the variables is squared. So find which other variable is squared, which in this case is so I'm going to put the x values on my left side. I'm going to move both my y and my constant over to the right side so that I can complete the square on the left. So x squared plus 2x plus blank, and then of course I'll need a blank on the right side to match. So 2 divided by 2 is 1, 1 squared is 1. Since there's no a value here, that means that these should match. So factor on the left, that gives me x plus 1 squared. On the right side, that gives me negative 2y minus 6. But notice that our format, we always have it factored unless there isn't a constant afterwards. So I need to factor out the whatever is in front of the y. In this case, it does happen to be the GCF, but sometimes you have to factor out and make a fraction. So that's going to give me y and then plus 3. So here's my standard form equation. The x is squared and the constant is negative, which tells me this is going to open down. I know that the 4p value in this case is negative 2, because that's my constant, which means that if I solve for p, I get negative 1/2, because I'll need that for my graph and for my focus and directrix. So the vertex HK, H is always with the x, so that would be negative 1, and then negative 3 for the y coordinate. So this is my vertex. To find my directrix, because it opens down, that means I'm going to go the opposite way. I'm going to go up to get to my directrix. Because it opens down, I know that my directrix is going to be a horizontal line. So directrix is going to be a y equals. So because p is negative 2, negative 1/2, I'm going to go half a unit up from the vertex. So negative 3 up half a unit is negative 2.5, which is negative 5/2. My focus, remember, is always on the inside of the parabola. So whichever way it opens, that's the direction you go from the vertex to get to that focus. So in this case, I'm going to go a half unit down to get to the focus. So negative 3 minus a half is negative 3.5, which is negative 7/2. It has the same x coordinate. So negative 1, negative 7/2. So here are the key features it asked me for. That's part of my answer. And then I need to draw its graph. So negative 1, negative 3 is my vertex, my focus. I'm going to go a half unit down. So little baby movement down for my focus. My directrix is going to be a half unit up. So here we go with that. Now, here is where we do have room and we need to use this 4p. So at the focus, at this half unit point, my parabola needs to be 2 units wide because the absolute value of -2 is 2. If it's 2 units wide total, that means 1 unit on the left side, 1 unit on the right side. So I go 1 unit in either direction from that focus, and those are points that I'm going to actually connect. That makes sure that the parabola that I'm drawing has the correct width. All right, last one. Similar to what we had in A, but this time the y is my squared variable. So that means keep all my y's on the left side, move all my x's over to the right side. And here when I complete the square, 6 divided by 2 is 3, squared is 9. Again, there is no number in front to factor out, so I know the blanks are going to match. So this gives me x minus 4, and this is y plus 3 squared. So in this case, I don't have something to factor out, which means that technically 4p is equal to 1 because there's nothing in front, which means the constant is 1. So that means p is 1/4. It's really, really tiny. So my vertex, again, be very careful. Don't just look at the first and then the second, the left and the right. It's x first and then y. So the x coordinate should be 4. The y coordinate should be -3. Because my y is squared and my constant was positive, that means it's going to open to the right. So 4, -3 is right here. And I know that my focus, I'm going to go to the right because that's the direction it opens. So focus, I'm going to go to the right and I'm going 1/4 unit. So 4 plus 1/4, 4 1/4, which is 17/4. And it should have the same y coordinate. So try really hard to just go 1/4 unit here. Then I'm going to go 1/4 unit to the left in order to get my directrix. Because it opens horizontally, that means that my directrix is a vertical line. Excuse me. So it should be an x equals, and I'm going to be doing 4 minus 1/4. So that's 3 3/4 is what we get. So 12 plus 3 is 15. So 15/4 would be the equation of our directrix. So I'm going to try to draw it in here. Really good. Again, it's super close to that vertex. So now in order to draw it, don't just freehand it. You do need to always use that width at the focus. That width at the focus actually has a funny name. It's called the lattice rectum, but people always giggle when we say that. So we just typically say width at the focus. So width at the focus is 1 unit, which means half a unit, in this case up, and half a unit down. So half a unit up, half a unit down. You can see this is a very little guy, but I can connect it this way and that way. Now I've got the correct width. Everything about my parabola looks good. All right, that wraps up the conic sections. So we've done circles, ellipse, hyperbola, parabola. That is all of them. And again, don't forget, I know I've said it a lot of times, these formulas do not need to memorize. Those are given to you.